Adding the port forwarding table. Repeat process for all virtual machines. Logging into each virtual machine. So for the lab part 1 and part 2, I have the virtual machine set like this with two PCs connecting through a router. And here we have the router set up, running this script from top to bottom, setting up its interface IP address, the IP address for the first interface and second interface, and this is the first network's address and the second network's address. With this setup, we can run a script and set up the interface configuration. Also, for the two PCs, we can see here we type the IP address. Here we can see this is first PC's address assigned statically, and this is the second PC's address, also assigned statically, and they are connected through the router. So if I ping from PC1 to PC2, you see this PC1 can ping PC2, and we can do the trace route. So here we are tracing the route. Yes, we will first switch the router, which is router interface 1, and to the routers and to the destination. So the same occurs to the second PC. So here it traces from first to the router's interface, then to the PC's PC1's IP address. So this is basically the part 1, part 2's static routing configuration. So for the lab part 3, we should change the router from Vaga to VIOS. And here, this is my VIOS router, and I configure it to to be able to configure the deep HCP IP address assigning. So here, this is how I configure the interface. Show interface. Here we can see the two these are three interfaces, and the second and third one are facing two internal networks, and each one has its own interface IP address, which is the um, network address and plus two 254, which is its interface address. So this is the default router address for two PCs. So can show here I configure the service, HTTP service. I see these are two networks, one or two, and they are default router IP address are the IP address we configured before, and the range 0 means we should let the DHCP server give us the IP address range from 10 to 100. So any client starting with this network should get the IP address dynamically assigned from 10 to 100. So this is two service I configure, and here, oh, okay, let me access first. Show IP route. Here we can see these two interfaces are directly connected to these two interfaces. It's to its IP address. So this is how I configure the router. And for the two clients, we just put them up, and you can see here the DHCP will configure the IP address for us automatically. We don't have to assign the static address ourselves. Here we can see it's starting from 10, and it's dynamically assigned to this interface. And for the second PC, it is same. Here, the IP address, it starts from 2, and it's also 10, which is the first IP address available from the range 0, and it's dynamically assigned. So this is how two PCs are assigned with IP address dynamically. So we can see here, we can first we have to uh, shut down the firewall and change its default route configuration, because first we can see here its default route configuration is through this EMP0S3, which is another route interface that will route our ping signal to another interface, which is not what we expected. So we have to remove the first configuration so that we can. So the second one will be our default route choice. So in that way, this is a modified IP route. So this is the only one default VR 192 160 68.2.254, which is the router's interface address. And by that, we can ping the corresponding PC, which is the first PC. It has 1.10. So the same, same similarly, we can ping the other one here, right? We can ping each other, which means our network settings are good and doable. Also, it works for trace route. You can see here. Yes, this is pretty much the lab over 3 configuration. We changed Vaga into the wells, so we can assign IP address dynamically. So for the part 4, let's just use the same configuration. And the part 3, we have 2 PCs connecting through the WAS router using the dynamic assigned IP address. So the first IP address is this one, uh, 1.10. And the second IP address is 2.10. So here we are going to run a code and let the first PC be the server and let the second be the client, and let the client connect to the server and send a message. So here I use the VS Code to connect from my host PC into the PC1, and I created a file named server.c, and this is the function. So this function will open the socket and listen for the connection and read the message and send the message. So here we can see it started listen and accept the connection request and read this buffer message and will print it out. So so this is how the server program works. And then for the client program, I just use Vim to edit it. It is called client.c. You can see here it's similarly working. We'll start by inputting the server's address and port name and send a message. This is pretty much the easy program. So for the server, we can just so here I already compiled this file. We can like gcc server.c output server. So this is the server file, and for the client we can do the same gcc client.c client. Oh, not sure. So here I got a client and the executable server. So all I need to do is open the server, choose a port number. Let me choose EE542, and the server is running. And for the client, let's run it. Client, giving the IP address, server's IP address, 168.1.10 should be the server's IP address. Oh, yes. Give the save port number. So here we have connected to the server. Let me send a message. Hello world. And the server sent the message back. I got your message here. You see, hello world. So this is basically we are connecting two programs on different machines through different network. We are dynamically assigned IP address from the router. So this is basically how we can communicate through your router from different networks. So this is part 4.